cover tonight is joins in Kafka Streams. Why join? Why would you want to join records? There's several reasons. The biggest of which, you need to get a more complete picture of the data, of your event streams, if you will. You might have an Internet of Things set up where you're getting streaming events from, say, sensors on a truck. You get sensors from the truck itself, but then there could be other settings related to those the readings you're getting from the truck that would be such that you would want to join to get a more complete picture. Sometimes you want to do a stream table join where you have a stream. You also have a KTable, and you need to do a stream table join because your KTable might have some enrichment type data that you want to add. That'll add a more complete picture to. So with that in mind, let's go ahead and let me show you some. We've got a simple join here, and we'll expand on this some more. But for right now, we'll just start with this basic example. So you've got a simple stream here, and it's just string keys and a string value, but it's enough for us to, work with the example. So you've got this stream here, and I've added a peek statement so we can see the records coming in. And then we've got a second stream that's based off of another topic. And it's the same thing. It's going to output key values. It's going to just put into the console to show these. So what we're going to do, and it just shows the keys, we're going to just take the first stream called join with the second stream. So the first stream is the primary or the calling side. And the join, the secondary stream, or the other stream, if you will, is the second stream. So that's the first argument in the stream join. Second argument is the value joiner. Now here we have, this is represented, let me open up a, value joiner is a straightforward interface. It just has one method apply. So it takes value from the left-hand side, the calling side, and the right-hand side. You do something with it, and you return it. Now you should notice the generic types. You've got V1 for the input stream, V2 could be different types, but then VR, so you can return a completely different type. In our case, we're not going to. But in this case, in our example here, we're going to return the same type. It's going to be a string. But that doesn't have to be the case. And while we're talking about that, I want to see, there's also a KStream. We've got another method where okay, it's not in 2.8 yet. It's going to be coming out in 3.0, I guess, then. The value joiner with key. So we'll get rid of this. And what that is that gives you read-only access to the key when you want to determine that value. Say read-only, you could, in theory, do something with the key, but then you're going to get undefined results. So if you end up using the value joiner with key, which should be part of the Apache Kafka 3.0 release coming out very soon, don't modify the key. So that's the second argument, and then we're just representing this here as a lambda because all we're going to do is take these two string values and concatenate them together. Okay, and then we've got join windows. Join windows specifies, driven by the timestamp of the calling stream, so the join stream, you've got this duration of 3 seconds. So what join windows is specifying here is based on the timestamp of a record from stream 1 with a given key. You have, when record 2 comes in, it needs to be eligible in order to do a join. It needs to arrive within 3 seconds on either side of the arrival time of the primary key. So what that means is it's 7:07 Eastern time. So let's just say it's 7:07, no seconds, 7:07.00 seconds. So that means the record from the second stream needs to come in at 7:06 and 57 seconds, all the way up to 7:07.03 seconds. So you've got this. If it comes within that window, you'll get a join. You see, so I've got some comments here out with some different things, and we'll get to that in a minute. But that's a crucial part of the join. And then this is based on the timestamp of the record. So when we say join windows of 3 seconds, not wall clock time, not at all. You know, if you're running this again at 7 p.m. Eastern time, but your record comes in and it's got the timestamp on the record, is something completely different. It's based off of that timestamp on the record itself. So it's stream time. It's important to keep that in mind. Okay, then we've got stream joined, and that is a configuration object where you can specify certain parts of the join operation itself. So you can provide here. We're just doing surdays. This is the key surday, and then the value surdays for both sides of the join. And we've got a commented out section here, and I'll get to that in a second. So that, and then again down here, I'm just printing out the results of the join. And one of the things I'd like to, I guess there's no reason for you to not see this whole screen. The other thing I'd like to point out is on the properties for this, I've set the cache config, I've set it to 0 bytes, but we're not going to cache anything. So we're going to see these results immediately. So with that in mind, let's go over to, I've got this utility class, and we're going to send these records here. I mucked around with the time a little bit. So we're setting the instant, we're getting an instant of now, and we're sending the first record in for it now, and then we're saying less than 1 second on the other side. So I'm kind of mucking around with the timestamps here a little bit, but you'll see this, and we're going to create the topics right here. And actually, while I'm talking about topics, one thing that Kafka Streams is going to do under the covers is it's going to check, it's an important part of joins. It checks, it does code partitioning. It makes sure, because you have to have the same key. And it goes without saying, you need to have the same key. But they need to have the same number of partitions, because if you've got this key foo, it needs to be on the same partition. So if you've got a different partition count, it could end up on a different partition, and then you would never join. So one of the things Kafka Streams does under the covers is it checks that the two topics you want to join have the same number of partitions. But I'll show you an example of what happens if they're not in a couple minutes. But for now, let's go ahead and let's just produce this. We're running Docker here locally. Okay, there we go, and we just produced 4 records. And let's go ahead and start up our stream joins class. There we go, start it up. And there we can see here, records coming in, we're printing them out. And then the join key for 0 is the quick brown fox. And then here we can see the quick, and then came in, brown fox, the quick, but then it puts it in the right order. And then we've got jumps over the lazy dog, same thing. Properly joined our 2 phrases here. That's to be expected. So let's, I'm going to go ahead and stop our join windows here. Get rid of stream join. Well, let's do a quick. Before we get to the different join operations, let's talk about stream join config. It's gonna be a little easier to get through. So here we're going to show you that we're going to list the topics that Docker has here. And then you can see this. These are internal topics. I won't talk about these. These are all internal topics. There's our two input topics, input 1, input 2, output, the topic we wrote our results to. We don't really need to look at that because we saw the results here being printed on the screen. So that was output. So anyway, here you can see joining streams, that's the application ID. And then this, the uppercase stuff with this number, these uppercase number, this is an internally generated name driven by Kafka Streams. You need to give it a name. So KStream join other, that represents the state store for the secondary side of join this one. And then you've got the KStream join this 006. That I'm sorry, changelog, excuse me. These are the changelog topics. This represents the changelog topic for the state store backing the other side of the join. There's a state store there that's keeping records for the other side to look. And then this is the state store. This is the changelog for the state store backing the calling side. So you can see this, and this is a real simple example, so we kind of know what these, there's only one join here, super simple topology. So we know what these two, what they relate to. But you could, in a much more complex topology, after a while, these KStream join other with a number, you get lost in the meaning. It's, you look at your topology and you may or may not know what it does. But more importantly, if you add operators upstream or downstream to it, it will change the name of these because these numbers are generated. So what you can do is and it's always a best practice with stateful operators to name the state store and any possible repartition topics. We don't have a repartition topic here because we did not change the key. But if you change the key on either of these streams, you could end up with a repartition topic on the stream when you change the key. We didn't do that here, that's not the case. But what we've done here, we've got stream join here, we've got this config object. Now we're saying with name, phrase join. What this is, if there is any repartition topic, the base name for this is going to be phrase join. Believe the repartition topic name is going to be, doesn't have a Java doc there. The repartition topic name is going to be application ID dash this name you give it right here with name, and then dash repartition. So then it knows. But then with name, you can give it a meaningful name so you get a better idea of where it is in the topology. More importantly, as you add operators and redeploy, it won't cause a shift in the name, what it would do. So you would have a shift in the name, and so you would end up creating a whole new repartition topic. More importantly, with the state store name, if you do a redeploy, you always want to restore from that same changelog topic. Repartition topics, Kafka Streams deletes from there on a fairly regular basis. You still want to keep the same one, but it's not as much as with the state store. You change that name and then you redeploy, and let's just say you're either using in-memory stores or you wiped out the RocksDB, you wiped out the local state, and it's going to restore from scratch. Well, guess what? If you change the name of your state store, it's not going to restore anything.